Okay, so let us discuss the limit of a function. But before that, let us review first how to evaluate a function. Given, for example, f of x is equal to 3x minus 2. So we can evaluate this function by simply replacing x by a certain value to get the value of f of x. Say, for example, if x is 1, then we replace x by 1. Then perform the indicated operations. So 3 times 1 minus 2. So 3 times 1 is 3 minus 2 is 1. So if x is 1, then f of x is 1. If x is 1.5, then 3 times 1.5 minus 2 is 4.5. So 4.5 minus 2 is 2.5. So if x is 1.5, then f of x is 2.5. If, for example, x is 1.9, then 3 times 1.9 minus 2. So 3 times 1.9 is 5.7 minus 2 is 3.7. So if x is 1.9, then f of x is 3.7. If the value of x is 1.99, then 3 times 1.99 minus 2. So 3 times 1.99 is 5.97. Then minus 2 is 3.97. So if x is 1.99, then f of x is 3.97. Then if x is 1.999, then 3 times 1.999 minus 2. So 3 times 1.999 is 5.997 minus 2 is 3.997. So if x is 1.999, then f of x is 3.997. Let us now proceed to our topic, which is the limit of a function. So what is meant by limit of a function? The limit of a function, denoted by L, is the unique real value that f of x will approach as x approaches c. In symbol, the limit of f of x is equal to L as x approaches c. Say, for example, we have the given limit of the quantity 3x minus 2 is equal to L as x approaches 2 from the left. So here, we're going to find the value of L, or the limit of the given function. Based on our definition, to get the value of L, we have to look for the value that f of x will approach as x approaches 2 from the left, using the number line. And earlier, during our review of evaluating a function, we have already the data showing the value of f of x from its corresponding value in x. As we have noticed, as the value of x approaches 2 from the left, the value of f of x approaches a unique real value of 4. So, the limit of f of x as x approaches 2 from the left is 4. This time, given the same function, let us find the value of L, or the limit of the function 3x minus 2 as x approaches 2 from the right. Let us start from 3 as the value of x, going to the closest value from 2, which is 2.001. By the way, in a more convenient way, you can use a calculator for the computation. So, If x is 3, what will be the value of f of x? Substituting the value of 3 in x of our given function 3x minus 2, we have 3 times 3 minus 2. So 3 times 3 is 9, minus 2 is 7. Next, if x is 2.5, so 3 times 2.5 minus 2. So 3 times 2.5 is 7.5, minus 2 is 5.5. If x is 2.1, 3 times 2.1 minus 2. So 3 times 2.1 is 6.3, minus 2 is 4.3. If x is 2.01, 3 times 2.01 minus 2. So 3 times 2.01 is 6.03, minus 2 is 4.03. And if x is 2.001, 3 times 2.001 minus 2. So 3 times 2.001 is 6.003, minus 2 is 4.003. So as we can see, as the value of x approaches 2 from the right, the value of f of x approaches a unique real value of 4. So, the limit of f of x as x approaches 2 from the right is 4. If the limit of the quantity 3x minus 2 equals 4 as x approaches 2 from the left, and if the limit of the quantity 3x minus 2 equals 4 as x approaches 2 from the right, then the limit of the quantity 3x minus 2 equals 4 as x approaches 2. Generally speaking, the limit of f of x equals L as x approaches c if and only if the limit of f of x equals L as x approaches c from the left, and the limit of f of x equals L as x approaches c from the right. Let us now look at the graph of the limit of a function. Based on the given graph, the limit of the quantity 3x minus 2 as x approaches 2 exists because the limit of the quantity 3x minus 2 as x approaches 2 from the left is equal to the limit of the quantity 3x minus 2 as x approaches 2 from the right. Now, looking at this given graph, starting from the left, the limit of f of x as x approaches negative 4 from the left is not equal to the limit of f of x as x approaches negative 4 from the right. Therefore, the limit of f of x as x approaches negative 4 does not exist. While the graph from the right, the limit of f of x as x approaches 1 from the left is equal to the limit of f of x as x approaches 1 from the right. Therefore, the limit of f of x as x approaches 1 exists, and it has a unique real value of 4.